I think people underrate how much cost each line of Solidity code bears, because each extra line of code you have to audit it, you have to maintain it, you have to test it. It's a potential source of a bug. You have to pay for it, and I think a lot of technical founders underrate the cost in long term. So they're just excited and they write 2,000 line protocol, but then 6 months later, they found that their audit for 2,000 line protocol is like $150K. And my general advice would be try to write as less Solidity code as possible to achieve your product goals. And specifically, if you're not sure about some features, just drop them. Just try to launch absolutely minimal product and minimum Solidity code and see where it gets you. And another advice is, even in the bear market, try to launch as soon as you can, as fast as you can, and get first early adopters as fast as you can, because crypto market in particular seems to give a lot of a first mover advantage to protocols which launch faster.
Hello and welcome to another episode of Devs Do Something. Today's guest is Igor Yalovoy, a smart contracts engineer and former CTO of Babylon Finance. Igor has a really interesting backstory. Babylon was a DeFi protocol that ended up shutting down recently after the Rari capital exploit, but the team gave the whole project a really high integrity effort, and it sounds like they learned a ton during the process. Igor walks through what it was like launching a new DeFi protocol during the frenzy of the bull market, and he also talks us through the lessons he took away from the experience. We cover subjects like testing smart contracts, preparing for audits, optimizations, and fun things he's proud of that he built, solutions to the sometimes oppressive contract size limit in Solidity, which he actually just gave a talk on at DevCon. There's a link in the show notes you can find about that. And we also go through how he personally levels up as a Solidity dev. This episode is a treasure trove of information for DeFi founders and technical folks alike. I hope you enjoy. Are you a DAO or crypto native business with salaried employees? Or do you perhaps work for one? If so, whether you're a team of 5 or 500, your organization can save time and money by streaming salaries with Superfluid, who also happens to be the beloved producer of this podcast. With salary streaming, your management team no longer has to worry about executing multi-sig operations every month or manually executing hundreds of separate transactions to pay their team. Contributors and employees, on the other hand, get paid by the second, which, to be honest with you, is a pretty killer benefit on the receiving end. Those of us getting paid via stream can connect our wallet to the Superfluid dashboard and see our balances ticking up in real time. It's kind of mesmerizing and feels like you're being jacked 10 years in the future. When you're paid in a stream, it flows in perpetuity until your team needs to adjust compensation, which effectively puts Web3 payroll on autopilot. Salary streaming is easy to set up thanks to our recent integration with CoinShift, the leading crypto treasury management platform. In just a few clicks, you can securely set up payroll for hundreds of employees in just a single transaction, all from CoinShift's dashboard. If this sounds like something you're interested in exploring, you should visit superfluid.finance/payroll and book a salary streaming demo today. Thanks to all of our sponsors. Let's get on to the episode. All right, so we're here today with Igor. Welcome, man.
Well, excited to be here, and thank you for inviting me.
Yeah, no, a previous guest, Santiago, who I think it was episode 7 or 8, recommended that we chat, and I'm really glad that we were able to connect. The first question we like to ask, before we get into some of your other technical thoughts and maybe some things on Babylon and your other work, is how you got involved in crypto.
Yeah, it's quite an interesting story. I've been in crypto for many years now, and I first heard about it in the university many years ago, and I just thought it was only Bitcoin at the time, no Ethereum. So I thought, oh, it's like a very nice idea, but totally unpractical, and I slowly discarded it. But then I saw people, keep pushing it, and I thought, oh, maybe it's something more sustainable. So I decided to bought some Bitcoin, and because I bought some Bitcoin, I decided, well, I got to understand how it works. So I studied all the cryptography, all the underlying technology around Bitcoin. It was easy for me because I was a software developer at the time already. And then it kind of hit me really hard. It was almost like a magical moment. It was like a magical internet money. It's like, finally we can have something better than accounting books, which just like lie around the world. And then I did a project for Bitcoin. It was like a P2P exchange. And after that, Ethereum appeared. I was blown away again because, okay, you can write code for Bitcoin, but now you can write code on-chain, like smart contracts. And it was just like mind-blowing. So I started to play around with smart contracts, and that eventually led to me doing some projects. And eventually I got into OpenZeppelin, where I work on DevTools and OpenGSN and Defender and other things, and met a lot of amazing people there. And after that, I co-founded Babylon Finance, which is a DeFi protocol. And that's pretty much where the story ends right now.
Nice. Yeah, I had a similar experience where I got involved more just conceptually, right? Bitcoin white paper, started reading around, just reading articles from some of the thought leader types, right? Watching Andreas Antonopoulos videos and stuff. And then I actually decided to learn how it works, right? So I can relate to that big time. So you went from OpenZeppelin to founding an actual DeFi protocol, right? What was that like?
Well, I'm like a technical co-founder, and I want to give the credit for idea vision to Ramon, who is like the other co-founder. So it was mostly his idea that people invest as communities, not everyone, but some people. And it looked at there is no good protocol in DeFi at the moment which allows you to do it. Let's say me and my friends, we want to invest into something together and share all the profits and losses. There were no good way to do it. And this is the whole premises of Babylon Finance, as you can invest in various assets and strategies as a club. We call them gardens. And the breakthrough was that in traditional funds, like hedge funds and mutual funds, there is always a manager who is like legally responsible for everything that's going on, but he or she makes a lot of decisions. And in Babylon Finance, it was obviously non-custodial, so people had to vote on actually what kind of financial decisions they make. So everyone had their part of responsibility.
Nice. So you had this idea, you got involved with your co-founders who also obviously helped kind of incubate the idea. So I think what's interesting is for a lot of people that are engineers and have a lot of experience doing like more hardcore engineering work, the process of founding something feels a bit different sometimes, right? What was it like for you building the early MVPs and early versions of the protocol? Did you guys take a kind of move fast mindset? Did you go slowly because you're working with smart contracts? I'd love to understand how you thought about some of those early technical decisions.
Yeah, it's a great question. I don't know how our experience is typical for average DeFi project, but I'm totally willing to share it. So we had every founder was somewhat technical in our team, which was great. And we basically started building and launching the bull market. It was very clear to us that it's a bull market. And the bull market was special where it felt like every week you don't launch, you lose a lot of audience, TVO. So essentially, our development cycle was looking like a hackathon. We just sit down initially and the hack like V1 protocol like very fast, and the DApp was also hacked very fast. And then after we had our MVP, all our contracts were upgradable, and so not only we like shipped the V1 very fast, we also were constantly upgrading features, adding new features, and the whole like life cycle was insanely fast. I mean, I think it was like the fastest moving project I ever worked, because we literally could feel how like the power market was like moving projects and capital forward. So every week it felt it matters. To give you an example, I was responsible for most deploys on our protocol, and we would have just like months where I would deploy some contracts mainnet every week, like literally like every week. Well, our protocol had many contracts, so it's not like everything deployed every week, but we were like, okay, this is done, like ship it. And obviously the biggest concern for us was the security, because, well, first of all, security is like number one priority if you build DeFi protocol. And second, sort of auditors, they don't move that fast, especially like the popular one, the good one, you have to book them ahead and they don't move up fast. And so you have this sort of dilemma: do you launch now without having like a proper audit, or you wait for a proper audit and you launch then? And sort of my conclusion was that even you have an audit, you're likely to have some changes after this. So essentially you should not rely on audit as being silver light bullet. You should build like your own internal security processes from day zero, so you can rely on them mostly, and then audits is just sort of a cherry on top of a cake. And we were like very test heavy from the start, and especially we had a lot of like integration tests, essentially mainnet fork tests. And sort of my security model was that as a protocol is a black box which money goes in and out, and if you can isolate with tests well with parts where the money goes in and out and test them really well, then it's hard to attack. And I think that was allowed us to iterate fast without compromising security much. Essentially, you have these parts where you move money in and out, and they like more sort of you like more careful around them. But then a lot of things in side protocol, where like the money moves the side protocol, then you have like more freedom around there. Hope it gives like some insight of what kind of like vibe and culture we had there. And I guess the final part, a lot of it came at like a cost of personal sacrifice of founders, is not having like vacations and working on weekends, which was like quite stressful. And so to answer the question about balance, there was like no balance. I mean, it's just like work.
Yeah, the bull market by itself, even if you weren't a founder, was crazy. I can't imagine it as a founder in DeFi itself, right? It was probably very intense. One question for you on the integration test, right? I think, do you have any general advice on testing code that's being touched by a lot of different contracts and other protocols in the ecosystem, right? Because I've seen a couple different schools of thought on this, right? I've seen some people say that you should create mocks for everything, right? And just try to mock up different situations, provide inputs to the different mock contracts, or using the mock contracts to provide inputs, use fuzzing. But it sounds like you forked mainnet and you try to just get the best simulation that you could, given where the current state of the chain was. Like, I would love to understand, like, whether or not you have any general advice on testing contracts that are very composable like that.
Well, it's an excellent question, and I haven't seen much of this work done in the wild. And our solution to this was because Babylon Finance was aggregation protocol, so it would use all other protocols, Compound, other Uniswap, Synthetics, many of them, is we had essentially 3 layers of tests. And I called them essentially unit tests, integration tests, and end-to-end tests. And this is about only like Solidity protocol. Unit tests are pretty common. This is what you see in all the Solidity tutorials. And then integration tests, a bit more tricky. You want to test how components inside your systems interact with each other, but you don't want necessarily test like all externalities like Uniswap exchange or compound. So you would write mocks for these protocols, which like would have reasonable assumptions and return some like easy numbers to test. Let's say like fixed prices for exchange, like one Ethereum is $1,000, which allows you to build somewhat sound tests, which are easy to write and easy to maintain. And then finally, you would have what they call yen-to-yen tests, is where you would just go full hard fork mainnet, and you would literally mainnet fork all the protocols you use, like Uniswap, Compound.
All right, so let's say that someone comes to you, right? They know you have lots of experience as a former founder of a DeFi protocol, and says, "Hey, listen, like I have this idea for a DeFi project. It's a good idea. I'm gonna go and I'm gonna be the CTO." You went through it, Igor. Do you have any general advice for me? This could be technical advice. This could be more like business style advice, or it could be personal advice, right? Well, what would you say to that individual?
Personal advice, like measure your pain tolerance. But let's focus on technical advice. I would say I'm reading right now quite a bit of like protocols, source code, just for fun. And I think people underrate how much cost each line of Solidity code bears, because each extra line of code you have to audit it, you have to maintain it, you have to test it. It's a potential source of a like bug. You have to pay for it, and I think a lot of technical founders underrate the cost in long term. So they're just excited and they write like 2,000 line protocol, but then 6 months later they found that their audit for 2,000 line protocol is like $150K. And my general advice would be try to write as less Solidity code as possible to achieve your product goals. And specifically, if you're not sure about some features, just like drop them. Just try to launch like absolutely minimal product and minimum Solidity code, and see where it gets you. And another advice is, even in the bear market, try to launch as soon as you can, as fast as you can, and get like first early adopters as fast as you can, because crypto market in particular seems to give a lot of a first mover advantage to protocols which launch faster. Classical example is like LIDA versus Rocket Pool. LIDA launched a bit earlier, and they at the time Rocket Pool did launch their product, which is a great product. LIDA already had like 6 billion TVL, so it's like you're like 6 billion TVL later. It's not easy to like overcome, and I feel it comes in like many other like niches in blockchain. So try to launch as fast as you can, and try to write as least Solidity code as you can. And the final advice would be, make security is your priority number one. I see so many hacks, and honestly, a lot of them are embarrassing. You know, the mistakes they made are embarrassing for like Solidity developers. Just such obvious mistakes. And so to avoid these obvious mistakes, always focus on security, and focus on your in-house security. Don't like rely on audits to solve all the problems for you. It's not what happens. So essentially write tests, like define processes, how you like upgrade things, have a multi-sig for operations. You know, don't use like your hot wallet and MetaMask to just like upgrade the protocol. You know, it's like put focus on dev operation security as well, and security in general. So it's rather better to have a minimal secure protocol which will outlive all the competition, because all the competition gets hacked, and just in a couple of years you're like the only one staying there.
Yeah, that's one way to stay around for sure. Just outlast everybody. Don't get hacked last, or ideally don't get hacked at all. So going back to your time at Open Zeppelin, right? I think you were in an interesting spot where you went from someone I would imagine building tooling for this space in some capacity, maybe even on the audit side. I'm not sure what you did there, but you went from that side to actually probably using the tooling and having to operate and like ship a real product, right? Using some of that tooling. Do you have any specific perspectives on the kinds of tooling that you wish people would build for this space after going on the actual founder and protocol side?
I think as all developers, we appreciate tooling. Tooling is great because when there is no tooling, you just do tooling for yourself. And I think it's fair to say the tooling in Web3 is, first of all, lacking compared to traditional tech, the Web2. And it's also underfunded because if you're doing tooling, you're not launching this new exciting token. This is not handing you millions of dollars. And it's mostly made like, it's like a public goods domain. Okay, Gitcoin is doing something to help with this, which I appreciate a lot. But unless you can turn your tooling into some SaaS model or some token model, it's very hard to earn money with this. And as like a DevTools developer, which I was at some point in Open Zeppelin, you just see this like huge space of dev tooling. It's literally infinite. It's like any direction you look, you can improve things, you can make new things, you can like 10x things. And there is just not enough time or manpower or knowledge. It's such as like underinvested space in all directions. And I'm really excited to see what's like tooling be in 5 years. I imagine it's going to be like much better. And I hope we just can like enjoy our development process more. And it's like funny. My story particularly is very funny because I was working on Defender, which had like a set of components out at task layer. And then I just transitioned from Defender to Babylon Finance. And we just started to use it like from day zero. And we used it like a lot to send like automated transactions and to run basically AWS Lambdas for things we have to do at the protocol. And it was like a great help because sending transactions in an automated way to Ethereum is not an easy task. You know, you can hack something simple in like a weekend, but your transactions eventually going to stuck because there are a lot of edge cases around sending transactions to Ethereum. And this is what I've seen a lot of other projects struggle. Essentially, every time you have insufficient tooling, you have to invest like your resources and effort in improving these things. But as a startup, you have no time for like anything extra. You barely have time for a product. And so if you're a startup, you have to spend time on doing not like your main product. It really brings you down because you just can't afford it. It's like as a startup, you'd rather pay, I don't know, like $1,000 a month to solve a problem, which is not like your core problem, than to spend like very limited time of your engineering team on building the tooling. And I know some like bigger companies or mobile funded companies, they can, just like produce public goods for everyone. And I appreciate the effort. But I think most startups just not in this position where like the whole engineering team is like 2-3 people. You just can't like dedicate one person to write, let's say, like a hard hat testing library, right? It sounds great, but you just don't have this budget in terms of time and effort.
Yeah, that makes total sense. And I'm sure you had a really good perspective on it when you did make that shift, right? So, okay, let's say someone comes to you and they're like, hey, I'm either an entrepreneurial person or I just want to build some really useful public good. Was there anything in particular that really stood out in your time at Babylon that you just wish someone would have built for you guys?
Yeah, I think I had to write quite a lot of custom scripting around deploying contracts because Babylon is a complex system. It had about like 20 contracts on our like deployment script. And we used Hard Hat at the time, and Hard Hat had this like naive sort of how do you deploy a contract script, but it wasn't like any good for like real production system. And then I discovered like a plugin for Hard Hat. It was called Hard Hat Deploy. I mean, it had its own issues, but I built like more robust system on top of it, which was a custom power project. But again, as I'm saying, if you have to build like a custom tool for your project, it's probably not a good sign. And I know Hard Hat is now working on this project called Hard Hat Ignition, which is like advanced deployment system. But as far as I know, it's not yet published or live. So this problem is still unsolved. And I recently looked at like Forge deployment scripts, which you're supposed to write in Solidity. And in my opinion, they even less sort of ready for battle test production ready system. And I think this niche is pretty much unsolved to this day because you want like certain properties from your deployment system that it can recover if like your internet fails at some point, that it can manage like gas pricing spikes, because like in the bull market, if you deploy a lot of contracts, it costs a lot of money. So it's not like you just want to deploy contracts, right? You want to deploy contracts at certain price and a certain budget, which is like never mentioned in these Solidity tutorials. It's like, oh, just like deploy a contract, and then like deploying contract at current gas price is like 20K. It's like, all right, yeah, great. And you need all sorts of like features which allows like recovery, controlling gas prices, and like extra deployments after you deploy. So let's say you deploy and then you only want to redeploy certain components, and then you want to be able to specify like different deployments parameters on different chains, or maybe some arguments has changed. There is like a big leap between going from like Solidity tutorial deployment where everything is like shining and butterflies, to going to this like brutal real world where well, another example, it's like sometimes deployer has quite a few rights, right? And then maybe you want to deploy from like a multi-sig or from a hardware wallet, which is also like ISO lacking support for this. I mean, there is some support, but it's also not ideal. And I mean, if someone makes a product which address this like sort of high stake production ready systems, I would be like super happy to see everyone to use it.
All right, you heard that, boys and girls. Igor's looking for nice, robust, high quality deployment tooling. I think that makes a lot of sense, right? I think you're absolutely right. There is a huge delta between the beautiful, easy world of the Solidity tutorial and production. I'm totally with you there. So you made a comment earlier, actually, as well on lines of code in Solidity, all carrying like a lot of weight to them. A similar topic here, right? This is a little bit less on security and more on just a DevX thing. But you gave a presentation, a very good presentation, by the way, at DevCon about contract size limit. And this is something that I think most people that have written Solidity code and smart contracts have run into. There's this really annoying 24 kilobyte contract size limit, right? Where if you're trying to write a very complex system, you're probably going to run into this at some point, unless you're somehow very smart or very lucky. So can you give us an outline of, the problem and some of your potential solutions and the potential routes for getting around this contract size limit?
Yes, it's a favorite topic of mine because I personally suffered immensely from it. And I recently discovered I'm not the only one. I believe you had Nicholas from Balancer on one of the episodes, and I can quote him. He said, contract size limit is bane of my existence. And I think it's very poetic. I love it. And I think it's a perfect trap to a lot of founders and projects, because if you have upgradable contract, then eventually there will be more features. You'll find some bug fixes, and each like Solidity compiler seems to generate more and more fatty code. And as your project like naturally evolves, you eventually hit this like 24 kilobyte limit. But if you haven't thought from the start about this limit, you are in a very nasty position, because all sorts of optimizations for bytecode, which are like external libraries or bytecode golfing, they have major drawbacks. They're gas inefficient, and they may possess security risks, and they don't solve the problem in this sort of grand way where you literally has like unlimited control size, where you can write as many code as you want. And a transition from already existing project with a contract size limit to truly unlimited contract size is somewhat technically challenging, and there is no good materials online as far as I know. Finally, with some light shed on this problem, we have this EEP 2535 by Nick Match, and then there is like some work which Synthetic does, and then there is like my presentation with some slides in the repo. But I feel we're still very early. I think eventually for upgradable protocols, it will be sort of a default to be unlimited size, because protocols get more complicated, and the like Solidity compiler produce more and more bytecode with each version, but the bytecode size limit doesn't move anywhere. So I feel the future is that everyone will default reasonably to like one or the other architecture to our unlimited size contract. I think I'm drifting slightly away from like original question, just to give a bit more experience that at Babylon Finance, we didn't design our sort of clubs or gardens, which is the main contract for holding all the assets, and originally to be unlimited size. And that was like a big problem for us. We did bite-sized golfing for some time to like put more and more features. But at some point, I felt it starts to compromise our securities, because if you have to remove some code to get more space, you have just a few options, and one of them is basically turn some lines, Solidity lines, to assembly, which kind of do the same. But now you're in this like assembly realm where you don't have this like, compiler guarantees anymore, or you can sort of compromise some security checks, which you should never do. And I mean, it's like a terrible idea. I advise never anyone to do it. But I've seen, people do it for like to reduce the bytecode size. And these are like basically deadlocked. So you have to go unlimited size from this point. And this is what we had to do, and we did it successfully. And I can give more details, but like back to you.
Yeah, I think, you do outline why it's an important problem, right? Because you don't want people to compromise on code quality just to meet some arbitrary limit. That seems dumb, right? So I guess one follow-up question on that is like, so you went through the different in your talk, and I'll be sure to link to the talk. You guys should go watch it, especially if this is a curiosity of yours. But in your talk, you outline like the three approaches, right? So like external libraries, I think you had like the precompiled router and then the dynamic router. Each of those have trade-offs, right? But which of those, if any, do you have a preference for in your own work and in your own contracts?
Well, my own opinion, and I think external libraries are not a great abstraction in Solidity at all, because external libraries is just abstraction over delegate code, which is EVM or P code, but it's very limited in a sense what you can do with it. And it seems to be gas inefficient, is like pointed out in my slides. And so I think for some serious production projects which handles millions of dollars, you wouldn't use it to achieve unlimited contract size. And then your only real option then is to use some kind of router. As you mentioned, there is two of them, is a static router and dynamic router. And the only difference, well, we have a difference in gas overhead costs. The dynamic router is more expensive, but they essentially work in the same way. The only difference is that a dynamic router is fetching implementation for a method signature from a contract storage, where the static router has each implementation address precompiled for each method signature, and so it can't be upgraded. And I obviously advise to go with static routers if you can. I mean, if you're not planning to upgrade your protocol and it's like set in stone, it's like super great, because static router is great. It has the best gas efficiency, and it doesn't have any sort of security concerns because no one can update implementation. So there's no way you compromise your protocol by adding this like a malicious function which just like transfers all the funds to the hacker. But the reality is that many people will face bugs in the future, and the standards change and product needs new features. So many projects will go with dynamic router because they just need this functionality. And here again, you can get like this reference implementation of EP 2535, which is like pretty good level right now. I recommend everyone checking it out. But there can be other sort of implementations. The notable one is with this import with a pretty cool proxy, which is called Beacon proxy, which we use at Babylon Finance. It's then you have many instances of the same contract. Let's say like a typical example of wallet, right? You don't want to deploy a new wallet contract for each user. You can just use the same implementation contract to save on gas. So instead of deploying implementation contract for every user, you should deploy the minimal proxy, which just like points to a wallet, and you save a lot on gas for users. And we did the same for our gardens. They were Beacon proxy, and Beacon proxies, I haven't seen a Beacon proxy dynamic router implementation out there. So you would, essentially what I'm saying, depending on your project, you would need to get creative of how you combine these like proxies with dynamic routers, because the dynamic routers does use proxies. The proxy has some like different usages, where various kinds of proxies, I guess what I'm trying to say. And I would say the most important part is that you sit down at day zero and design your architecture, because these are the most important things. You can't really change them very well down the road. So you should absolutely be sure whenever you need unlimited size contract or not from the start. So if you're like a Solidity dev or a technical founder and you're just about launching your project, you should really sit down and think really hard on will you hit this limit and not. And I suggest to be rather sort of pessimistic than optimistic. So if you're not sure, then probably go with unlimited contract, because it's better, to overspend a bit on the gas than to be really sorry like 6 months later.
Yep, I think that's good advice. And thanks for giving the overview and the mention of that beacon pattern as well. I think that'd be interesting to see someone pair that with a dynamic router. Maybe a listener can do that and send it to us. So when we talk about optimizations, right? One question that I like to ask a lot of people that come on that are Solidity developers is how they think about gas optimization and gas golfing, right? So let's say someone comes to you and they say, "Hey, listen, I have this protocol that I have an implementation for. I haven't really deployed my contracts yet, right? So like, I have some time where I can go back through and make some optimizations. How should I approach this process?" What would you say to that person?
Great question. So on the personal note, I think gas golfing is an excellent game. I think we need to make some like EVM gas golfing game and leaderboard, and everyone can play it. And then we can know who is like the best gas golfer in the world. It's very valuable. But on like product side and being like reliable engineering and doing serious engineering, I would say, first of all, like never do any premature gas optimizations. I see a lot of protocols that just like starting to write code, and you look at it and it's already using a lot of gas tricks. I would say generally don't do that, because it makes code harder to read. Always like weird inverted for loops, and when you increment the counter, it's like and especially like if you use some assembly or even like pure EVM code, very hard to follow, very hard to audit. Your auditors will be really upset about it. I can guarantee that. And then just leave gas optimizations until the end before deploying. And then if you at the point before deploying, I would say you have to understand that there is a cost to gas optimization, and it usually comes at cost of security. So each gas optimization is somewhat compromising security whenever you believe it or not. It is my opinion. And then what I particularly did for Babylon Finance, I basically built a heat map of all the functions, essentially how often the functions are called and who is calling them. For example, we had like admin module, which is like admin functions, which are called only by like team and privileged accounts. And I was like zero gas optimizations for that. Like we don't care about the price. It's like we call them rarely and we call them ourselves so we can like eat the bullet. And then our like core optimized gas functions were basically deposit, which you put funds in, withdraw, puts funds out, and then the claim, so you can claim your rewards. And these are like the most, I guess, sensitive functions because like your average user is like paying their hard-earned dollars to call them. And these are the functions we were really guess optimizing because we wanted to give our users the best deal. But we have a lot of functions which were like had like shared costs between all the users that were paid by the DAO. Essentially, like we're like less sensitive to the cost, and we were not like putting any gas optimization effort in that. Essentially, I guess what I'm saying, unless there is a specific financial reason to gas optimize a method, just like don't do it. It's like we developed the whole concept of high level languages, so we don't need to write an assembly. I mean, I know some people write the assembly, but please like leave it for your hobby projects. Don't like bring it to like the major protocols. Yeah, I guess that's like my standing on this. It's a bit opinionated, but it is what it is.
Yeah. I've heard similar opinions actually. So I interviewed Sam McPherson, who's an engineer at Maker, and his quote on it was, "It doesn't matter how optimized your contract is if it gets hacked, right? All the gas savings go out the window if you get hacked." So worth keeping that in mind. One other thing, so you mentioned auditors a couple times in here, right? Namely that auditors might not like if all your contracts are all written in assembly. That might not be fun. But so, I mean, you spent time at Open Zeppelin. I don't think you were an auditor at Open Zeppelin, but Open Zeppelin does audits, right? So that's part of the mindset maybe of the organization. And you had to engage auditors as a CTO of a DeFi protocol. Do you have any advice for someone that is going to engage auditors for the first time? Like how do you prep for an audit?
Yeah, certainly. So yeah, I've been again lucky at Open Zeppelin. I wasn't an auditor, but I was working close to them. I'm friends with many of them. I kind of understand their mentality. And then at Babylon, as you say, I had to be on another side of the table. I mean, the good part was I already knew many companies and auditors and had like good connections with them, so we could work together. And I do have advice, and it's mostly like non-technical advice. To be fair, I think this is where people fail in non-technical stuff, because auditors, they had their own set of like goals and values and expectations when the projects you deploy. And I would say try to book an audit as early as you can. It's basically if you committed to build a protocol and you have like a timeline and a roadmap, you just start messaging auditors like immediately, because for some good companies, the timeline can be like 6 months from today. So like 6 months is the best time you can get a time slot. So if you're not doing it immediately, you may be just not getting audit before you have to go like mainnet. And then once you get your timeline, try to like communicate to auditors like as much as you can, in a sense like what they expect to receive or what you expect to receive from them, and try to like understand how their process and how they do things. Is like how they rate the issues, right? What's considered critical, what's considered I don't know, high severity, or like can they like amend them? Basically, some people they don't want to receive a report which says, "Oh, you have a critical vulnerabilities," right? So then they message auditors, "Oh, actually we fixed the bug, so can you like remove it from the report?" And the auditors like, "No, we can't," and then people get upset. So I guess just to try to understand the process and try to communicate well, especially if it's your first time. I would suggest go and read previous reports of a certain company to get an idea what you're getting, and just put people first, right? If there is some kind of an issue, just like don't expect the worst, expect the best, and try to communicate and just be like polite and humble. I guess what I see in this field is a lot of companies, they fail mostly on this sort of social side of things, not the technical, because there are like misunderstandings and that they're handled well, and that kind of results to delays and people being upset on both sides. Yeah, that would be the advice.
Yeah, that's good advice, and I appreciate you sharing some of the thoughts there. Right, I do think that some of the social things are probably where most of the misunderstandings arise from. right? It's just, it's how you'd handle any other business relationship, but it's worth keeping that in mind, right? Everyone's really proud of the work they've done, and they don't like back and forth necessarily come up with auditors, but sometimes, they're just doing their job, and you're better off assuming positive intent always. So I think that's good advice. Okay, on some other fun things. This is a question we like to ask a lot, right? Because everyone always has a kind of an interesting answer to this, but are there any really interesting optimizations or design patterns that you've implemented somewhere, whether it's in the Babylon code base or somewhere else, that you're just really proud of and you'd like to call out?
Yeah, I'm working on one thing right now, which I publish rather soon. And I was genuinely surprised no one did it. It seems somewhat obvious to me, but I talked to some best people in the field, and they're just you're right, but we were busy with other stuff, so we don't have time to do it. Which again, I guess probably our field is so immature that you have a bunch of low hanging fruits. There are probably a lot of them, and it's just not enough people just to go and collect them. And so my idea, I call it now a loaded proxy, which I'm working right now. It's very simple to explain. So I will use USDC as example. USDC stablecoin is a smart contract, and it's a proxy smart contract. And it's super quick how a proxy smart contract works. When you call a contract, you actually call a proxy, which then through diligent calls the implementation. And the issue of a proxy contracts, it has a gas overhead, namely diligent call plus surrounding packing arguments, gas costs, and it can be somewhere from 2,500 gas to slightly more values. And then and all the methods of USDC as a coin, they're proxied. So any method you call, you pay the gas overhead premium. And then ERC20 standard has functions like decimal, and decimal function is USDC. It returns just a number, which is a constant. I forgot what it is, 8 or 6 decimals USDC use. And if you look at the gas cost of USDC returning the decimal method, it's 150 gas. Literally, is the gas cost of this method of implementation. But if you call it through the proxy, it's 2,600. So it's 98% gas overhead to call in this method. And the number of this, and then why this method is important, when you use USDC inside your DeFi protocol, you have to know how many decimals your C20 token has, because if you don't know, you can't do the math and value it. And so every protocol which uses USDC is calling the decimals. And every protocol is overpaying this gas on this method. And with just millions of transactions, I'm actually going to run a Dune script to just see how much money were wasted. And so my proposal, I call it loaded proxy, is that you put the methods which return constants, not on the implementation itself, but on the proxy. It's what's the chance your contract will change the number of decimals it's going to return? It seems impossible. I mean, if you're going to change the decimals of number of USDC is going to return, you probably have an issue, right? And this will result in 99% gas efficiency for this method. And with other methods like this, symbol, right, is also constant. Essentially, any method which is a constant, you can put it on the proxy itself instead of implementation because it's reasonably safe. And then I talk to people who are good at this stuff, especially at OpenZeppelin. Why it's not been done? First of all, we're busy with other stuff. But another good answer is that there is this canonical code of a proxy contract from OpenZeppelin, which is everyone afraid to touch, right? Because you touch it and things explode, and you have to put code on this. And then another answer, actually, it's pretty funny because it's go back to the original conversation. There is zero tooling for this, right? Even if I publish it tomorrow and explain everything step by step and how cool is it, there will be still zero tooling to sort of automate it, to make it secure, to make it checks. The best you can do is probably write tests that your contract still performs as you expect. But there still will be zero tooling for this. You would literally have to go and to sort of write your proxy on proxy, probably inherit from OpenZeppelin. And then you would have to inherit from some like implementation part, like return this like decimal number for ERC20. But essentially, you have to do the work yourself with no like any tooling or library which will do like all the heavy lifting for yourself. And you have to be responsible for all this. And then we go back to that, it's just like a gas optimization, right? So why would you like risk your protocol for a gas optimization so no one does it? But it's sort of stupid because we can save a lot of gas. So it's kind of interesting topic, I would say.
That's really interesting. I had no idea that was actually happening, right? I mean, the root cause problem here with USDC in particular is whoever at Circle decided to make it 6 decimals or 8 decimals or whatever it is, just is putting us all through it. But, I'm glad people like you were thinking about how to solve for this after the fact. So that's good. A couple other questions for you. I know we're running up on time a little bit. One a little more specific toward technical stuff, and then one where I'll zoom out. But the first one is, I mentioned that a lot of people that listen to this, they like technical things. They honestly, a lot of the stuff you said today I think it's going to be great for people to hear just in terms of learning and for approaching the process of building a protocol. But what have you done personally throughout your career to level up as a developer? Is there anything you do in terms of personal development, any habits you have that you think if other people adopted them, that it would also help them?
Yeah, I mean, I've been a developer for 15 years, so I think I'm going to focus on Solidity stuff because I guess the most audience is around this. So I like that in Solidity we're in this like really new innovative world, and there's a lot of great games which personally helped me a lot to have fun and just polish my skills. So I highly recommend doing OpenZeppelin FRNow challenges if you haven't done them. Even if you're like a pro, still do them because they're just fun. And then there is a them venerable DeFi, which is like sort of challenges focused on DeFi, pretty fun to hack by Tincho. And then there is an amazing challenge from Paradigm. It's called Paradigm CTF. It's run every year, but I think you can still solve all the levels, and they're like super advanced. It's like Paradigm CTF challenge is like on another level. It will make your brain to boil, but it's totally worth it. And then the second advice is, I would say, do like a shadow audits. And now you don't even need to do shadow audits. Just go to Immunify, go to Code Arena, and just like audit other projects. It will make you a better developer instantly because you will see new patterns, new like language constructs you haven't seen before. And you just like learning by reading it, by trying to hack it, by running tests. And the upside, you just get paid money. I just recently submit like one issue and just got paid like $1,000 on Polygon, and just like a fun, and it's money in the end. It's like super great.
Nice. Yeah, that's really good advice. I mean, some of the challenges on Damn Vulnerable DeFi and the Paradigm CTFs are all really good. I mean, obviously varying levels of difficulty, right? If you're going to go compete in the Paradigm CTF, you better be ready to go. But yeah, no, that's excellent advice. Okay, last question for you. This is much more general, but as someone who's been around crypto for a long time, right? You've followed this whole thing, right? Going all the way back to like some of the earlier Bitcoin days. You've seen some evolution in terms of the industry in the last 5 or so years, I'd imagine. What do you hope our industry looks like 5 to 10 years in the future? Right? What do you hope we build? What do you hope things look like?
Yeah, I'm gonna focus on dev side of things. And so I have 2 hopes here. First, around dev tooling. It's like if you go on the car level, if you compare dev tooling with cars, I think right now we're all driving these like right now super like budget, like cranky old rusty cars, and it can like get you from A to B, but the whole experience is like terrible. It's shaky, no EC, you're afraid of like accident, aka getting hacked. And I hope like in next few years, dev tooling gets so good that it feels like driving, like a Mercedes. So essentially, it's like enjoyable to use tool. They're so good. You just like, with like every tool you want, it's there and you just use it. I mean, it's fine if you have to pay money, but it's just there. And I hope we get at least to like Web 2 level tooling, which would be great. And my another point is that I hope sort of blockchain right now, if you look at tech in general, we have like front end, back end, desktop, mobile, and people there, they kind of, on some level, they isolated from crypto with sort of a negative connotation to the degree to blockchain development. And if you want to move, let's say, from, I don't know, mobile to front end, it's like nothing wrong with this, it's like fine. But it seems transition from like Web 2 to Web 3 has like higher cost of barrier right now. And I hope that Web 3 in blockchain in particular gets just to be like another job. You just can go to always like coworkings and meetings. It's like, oh, what do you do? I do like front end, I am doing blockchain, and it's just like fine. And no one has any sort of social preconstructs or preconditions. So people just like moving, transition fluently from blockchain to front end, back end, whatever, and no one even thinks it's a big deal or have like any negative connotation, because in the end it's just like technology, right? All the financial stuff, it just on top of the technology, but it's not inherently part of technology, I guess. And I think my other sort of wish is like I'm super excited about recent cryptography advancements, like zero knowledge proofs, polynomial commitments, and I feel like crypto is pushing cryptography forward like way faster than it used to be. And I hope we sort of grow cryptography to the point that it bears this like magnificent fruit of technology which can empower society and humankind. We can have this like neutral platforms and protocols for everything, and privacy for everything without compromising, stuff. So essentially, I'm like huge believer in solving things through cryptography. So, and I hope it like plays out in the next few years.
Yeah, very good answer. Very good answer. Yeah, I'm with you on cryptography. It's something that I had known about all like the code breaker type of stuff if you go back to World War II and that kind of thing. But a lot of the modern cryptography and advancements around ZKPs is very cool. I mean, it is moon math, right? So you got to really be ready to dive in if you're going to go get into it. But I'm with you. It's very cool. Anyways, Igor, thank you so much for coming on. This was a really, really good episode in terms of all the knowledge you dropped and shared. And I think our listeners are going to really like it. So thank you again.
Pleasure was mine. Thank you for having me. So much appreciated. And everyone, have a nice day.